Hello and welcome to the further maths videos for OCR Pure Core. This is Vectors for Equations of Planes, and this is video 4.4, the angle between two planes. Okay, so if we want to find the angle between two planes, it can be found using the scalar product. So we can see here, cos theta is A dot B over magnitude of A times the magnitude of B. So if we're trying to find the angle between two planes, it's actually the same. Here's the angle between the two planes as the angle here between the two normal vectors to those planes. And as we've seen before, where we often use the normal vectors in writing the equations of planes, this can be incredibly useful and make it quite straightforward to find it. So it's n1 dot n2 over the magnitude of n1 multiplied by the magnitude of n2. Okay, so example 1, we're going to find the acute angle between the following two planes. So first of all, we need the normal vectors. So n1, just straight from the equation of the plane, is 2 minus 3, 1. And n2 is 5 minus 2 minus 4. We're also going to need the dot product. So 2 minus 3, 1, dotted with 5 minus 2 minus 4, which is 10 plus 6 minus 4, so that's 12. So using the equation, we've got cos theta equals 12 over magnitude of this, which is root 14. 2 squared plus 3 squared plus 1 squared square rooted, multiplied by the magnitude of this, which is root 45. And if you calculate that on your calculator, you get 61.4 degrees. Okay, so the second example, we're going to find the acute angle between these two planes. Now, what you need to look out for is that sometimes your calculator may give you the obtuse angle between the planes, because if you think about the diagram, we can have two angles between the planes, an acute one and an obtuse one. So in that case, what you need to do is remember that the angle between the planes, that the acute angle is going to be 180, subtract the obtuse angle. So here, the normal vector to this plane 1 is 2, 2 minus 5. And the normal vector to plane 2 is 4 minus 3, 5. You can see these have been written in different forms. This is in Cartesian form, and this is using the dot with the normal, but it's still very straightforward to find the normal vectors from both of these equations. So exactly the same as we did before, cos theta is going to be, now when I do this dot product, I get minus 23 over square root of 53 times by the square root of 50. And that gives me that theta is 124.49. So it's very easy to make a mistake here and leave that as your answer. If we just look back at the question, it wanted the acute angle. So the angle that we're looking for is going to be 180 minus theta. So that is 55.5 degrees. And thanks for watching. The next video will be video 4.5, the intersection of a line and a plane.